Hello everyone, how are you? We are going to start IGCSE paper 4 extended version. Paper version is 42 May June 2024. In first video I have discussed the first three questions. Now we are moving towards the question number 4, that is related to uh, thermal physics. Okay, so question number 4 is that Figure 4.1 shows a stainless steel saucepan being heated on an electrical cooker. The saucepan contains hot water. This is your saucepan, and hot water you can see here in gray color. And this is your stainless steel. I think this is your metal plate from we are supplying the heat energy. So first question is that state what kind what happens to the water particles as the water temperature rises. Remember one thing, when you are applying the heat energy to any matter, here matter is liquid. As a result, thermal energy of your matter start to increase it. But in that case we are using in saucepan water, so water is a matter here. So what heat energy that you are supplying will increase the temperature of water molecules. So I have right here in one sentence. Second question is B part is the saucepan contains 250 centimeter cube of water. The specific heat capacity of water is 4200 joule per kg per degree Celsius. The density of water is 1000 kilogram per meter cube. State that the mass of the water in the saucepan is 0.25 kg. Here it is mentioned that you have 250 centimeter cube of water in the saucepan. The specific heat capacity of water is 4200 joule per kg per degree Celsius, and water density of water is 1000. Remember one thing, density of water and specific heat capacity of water both are the constant quantity. Okay, sometimes values of density and heat capacity is given. Sometimes you have to recall your memory and memorize it. Okay, show that the mass of the water in the saucepan is 0.25 kg. You have to calculate the mass of that water that is used in the saucepan. So you have one thing, remember one thing, density is given in kilogram per meter cube. I am highlighting it. And volume is given to 50 centimeter cube. So you have to convert volume into meter cube. Okay, so in that case, remember I have also delivered one lecture how we can convert the units from small unit into large unit and large unit into small unit. So if you did not understand those topics, then move towards playlist that is measurements, I think chapter number 1, where I have delivered complete lecture how we can convert the units from one unit to another unit. So centimeter is a small unit, meter is a big unit. So when you move from small unit to big unit, you have to divide with some value. So the question I have write out formula here: density is equal to mass per unit volume. Density, it is your uh, formula. Density is equal to mass per unit volume. Density is given, that is 1000. Okay, volume here is divided here. When it will come into the uh, left side, it will be multiplied by the density. So I have right here 250 centimeter cube, but I have right here divided by 100, 100 and 100. The reason is that 1 meter is equal to 100 centimeter. Is it clear? So if you want to move from centimeter to meter, then you have to divide with 100. Okay, so here we are using 3 centimeter cube, 3 centimeter. Okay, so you have to divide 3 times with 100. That is why I write 100, 100 and 100 here. 250 divided by 100 mean it will be equal to 1 million, and multiply by 1000, you will easily get 0.25 kg mass. So you will get your answer easily. I think you have understand which I have told you. Now move towards the second part. Calculate the energy required to rise to increase the water temperature from 20 degrees Celsius to 65 degrees Celsius. So in that case you have to apply the formula of specific heat capacity, that is equal to energy supplied to the water is equal to product of mass. C represent the specific heat capacity of the water, and rise in temperature. Rise in temperature means how much your temperature is rise from one temperature to another. Here it has mentioned that your temperature is rise from 20 degrees Celsius to 65 degrees Celsius. It means you have to subtract 65. uh, uh, 20 is subtracted from 65, then you will get rise in temperature here. I have mentioned the formula E is equal to mc t. Sometimes you will see here delta theta, but I write here only capital T. Okay, so you have to remember this formula. It is very important topic of that is related to P4 and paper 2 and MCQs. The mass is given is 0.25. We have find it in question number 1. 4200 is the specific heat capacity of the water, and rising temperature you have to subtract 620 from the 65 and multiply all these terms, you will get 47,250 joule. Is it clear now? So you have to remember it. It was very easy question. Now third part is the heater supplies enough power to heat the water in 39 seconds. So Snimba, the question is that the heater by which you are rising the temperature of the water, it has mentioned here the heater can supply enough power to heat the water in the saucepan in 39 seconds, but student measures the time taken to heat the water as 115 seconds. Why is it so? Why there is a big difference in 115 and 39? Practically and practically we are obtaining the time 115 second to heat up the water molecules, but if we apply the formula, then we can say that our calculation says that we need only 39 seconds, but practically we need 115 seconds to heat up the water. So what is the reason behind that? Why practically we require more time instead of calculated 39 seconds? So the reason is that when you are uh, heating up your water molecules in the saucepan, so in that case some energy is also, first of all, heat energy transferred to the saucepan. Okay, some energy is wasted to heat up the saucepan metal. Okay, and outer surface of the saucepan is open, it means there is no lid, so maybe heat is also lost from the water molecule to the surrounding. So that's the reason behind this we need more time to heat up the water molecule. That is why there is a big difference between the time 115 and 39 seconds. So you have to write here some energy is transferred to the surrounding. Is it clear? I think double R here. Next is the stainless steel saucepan is replaced with an aluminum saucepan of the same mass and wait, I will highlight it. Okay, saucepan. It contains the same volume of water. The specific heat capacity of stainless steel is 500 joule per kg per degree Celsius, and the specific capacity of aluminium is 890 joule per kg per degree Celsius. So explain how using aluminium saucepan will affect the time taken to heat the water. Remember one thing, the material that has more specific heat capacity, it means its temperature, it takes more time to heat up. Okay, the material that has less heat capacity, it means its temperature can rise with small by absorbing the small heat energy. So when you are replacing the stainless steel saucepan with aluminum saucepan, then you can see here the heat capacity of aluminum is 890 joule per kg per degree Celsius. It means if you are heating up your water by using the aluminum saucepan, then it require more time to rise the temperature of water molecule because its heat capacity is larger than the stainless steel. So I will write here aluminum has more specific heat capacity as compared to the uh, stainless steel. That's why it takes more time to heat up water molecule. Okay, by writing these two sentences you will get 1 marks easily. Now moves towards the question number is 5. Figure 5.1 shows two containers each filled with hot water. First container is made of metal and other is made up of non-metal. So this is metal. Now what happened? Okay, I think it is not working well. Second thing, okay, now move towards the question. The outer surface of the metal container is hot. Explain how electron transfer thermal energy through the metal of the container. The question is that the outer surface of this container is hot and you have to explain it with the help of electron transfer energy through the metal of the container. Remember one thing, a metal consists of, why it is not working well, just wait, just wait. I have to reopen the file. Okay, now it is correct now. Okay, basically in that case metals have availability of free electrons. Metal has availability of free electrons and free to move throughout the whole surface. Okay, and free to move throughout the whole surface of the metal. Throughout the whole surface metal. That's why the outer surface of the container is out. That's why outer surface of container will be hot as compared to the non-metal, because non-metal is good insulator, and metals are a good heat conductor. Next is the outer surface of the non-metal container is much cooler than the outer surface of the metal container. Explain why. A non-metal container thermal energy less than the metal. Basically, the non-metal surface has no free electrons because they are a good insulator and bad conductor of heat. That's the reason behind this. Non-metal container has no free electron. And second point you can write here, non-metals are bad insulator. Okay, next is explain in terms of molecules why gases are poor thermal conductor compared to non-metal solids. The reason is that if you have if you have any idea about the property of gases, the particle in a gas are far apart to each other. Gas particle are far apart to each other. So this is the big reason behind this, because the particles are not close to each other. That's why they could not transfer heat energy easily. So you can write two sentence, then you can get easily 2 marks. Gas particles are far apart to each other and they cannot vibrate. They cannot vibrate and collide. I think vibrate is enough. uh, Vibrate. That's why the gases are poor conductor as compared to metals. In metals, particles are very close to each other, and due to vibration and availability of electron, metals can transfer heat energy easily. Now this is very important. Figure 6.1 shows a thin converging lens used to produce a magnified image of an object AB. This is your converging lens, convex lens, and this is the position of your object AB. Okay, F1 and F2 are the principal focus. This is the line which is passing through the center of that converging lens's principal axis. Explain the meaning of the term principal focus and focal length. Principal focus mean, remember one thing you have to write here in this way, when the line parallel to the principal axis, I will write here, when the line parallel to the principal axis collide with the converging lens, then they bend towards the principal focus. So this point is called principal focus, and the distance between principal focus and the center of the lens is called focal length. Is it clear? And a focal length is represented by the small f. This is your two definition I have right here. So right here, line ray of light is of light parallel to the principal axis after collision the with the lens passes through the principal focus. Okay, yes, and the distance between the principal focus and the center of a lens is called focal length. Distance between the principal focus and center of the lens is called focal length. Yeah, okay. On figure 6.1, draw the magnified image of AB, show your working. So you have, I will move towards the whiteboard. Where is my whiteboard? Where is, yeah, this one. So there are multiple, I will upload one more lecture in which you can easily understand, I mean in which I will explore all the possible images that can be formed by changing the position of the object. So opened, yes, open, more towards the, yes, this one. I will raise, first of all I have to raise this, no, to raise. So no, it is not moving from this side. Okay, okay, this is our whiteboard. Now we have to find out the position of magnified image. This is your object. Remember one thing, two lines are coming from this object. First line, that is parallel to the principal axis, will collide with the converging lens, and it will pass from the principal axis, just like that. And second position, a second rays that will be emit from the top of the object, and it will pass through the center of the lens. And next we have to extend these two lines in backward direction. Okay, and next is from this point you have to just like that. Yes, yes, the point, if you extend these two lines back in behind the object, you can see this is the point where both lines are intersecting to each other. So at this position your image will be formed, and this image is called virtual image, because this image does not form on the screen. Clear? I think you have understand all the things which I have delivered to you. Now I will see you in the next lecture, where we will discuss further question 7, 8 and 9, and then 10, 11, 12. Allah Hafiz.